Hello everyone, my name is Xiangtai Li. It is my pleasure to present our work, Video Kinet, a simple, strong, unified baseline for video segmentation. This is a joint work of Peking University and ICIP and NTU. The goal of this task is to solve the video panoptic segmentation, where it requires to assign semantic class and tracking identity to all pixels in a video. So it has a lot of usage, including estimating drivable area, and semantic understanding of the surrounding, also pixel-wise tracking for motion planning. So, however, current solutions for video panoptic segmentation VPS have several shortcomings, including complex handcraft pipeline, also need post-processing or offline tracking. Another issue is that they tackle the segmentation tracking with specific task heads. So is there a simpler solution for VPS? Also consider other video segmentation tasks, including video semantic segmentation and video instance segmentation. The different tasks have different solutions. So is there a unified architecture to solve all video segmentation tasks, including VS and VPS? First, we review several related work. We start from the DETR. DETR represents syntax stuff using object query. Since then, several work improved the DETR by using mask-only detector, such as MaxDeepLab, MaskFormer, and Kinet. They are all unified segmentation framework, which can perform semantic instance and panoptic segmentation. However, why we choose Kinet? Because Kinet has more computation efficiency. It is faster to converge, and it also achieves stronger results. First, we perform some toy experiment. We directly inference Kinet on the video clip. We found that the same kernel represents the same instance, or including the same instance mask across the frame. Then we perform toy experiment. We found the original Kinet it can achieve good tracking results compared to the handcraft tracker such as Unitrack. Then we review the video Kinet. It is based on Kinet. Both the synth kernel and the stop kernel are randomly initialized, and then all the kernel are updated using the kernel update cat. It has 3 steps: grouping kernel, adaptive update, and kernel interaction. Then we show that our improvements on the kernel. First, we learn a kernel association embedding. We apply a mask-based assignment to associate the kernel. We adopt a sparse kernel association. Suppose V kernel in keyframe that are matched key kernel in reference frame. The kernel are learned with a temporal constructive loss. Second, we learning to link the kernel. In particular, we force the kernel to along the tracking head where multi-head self-attention. Then we learning to fuse the kernel. We propose to fuse the kernel at the last stage of the Kinet. Finally, we generate our work on VS and VPS. For VS, we remove the tracking branch. For VS, we remove the online tracking, but using a main kernel to represent each object in one clip. Our network achieved new state-of-the-art results on 2 VPS datasets, including KD-STEP and Cityscape VPS. We performed detailed evaluation study on KD-STEP, and we show that on strong original Kinet baseline, our work can still achieve significant improvements. We also achieve best performance trade-off and G-flop trade-off. Here we show an example of visual improvement over Kinet baseline. Here we show our video Kinet can achieve good result on long-term segmentation tracking and short-term segmentation tracking. Then our network can also achieve considerable results on VS and VSS. Here we present the video results on YouTube VS dataset. Thanks for your watch. All the code are available on the GitHub.